We have a lot of stuff for is it recording? Okay, should be recording. We have a lot of stuff prepared today. Um, so I think we'll very much go through the full 2 hours that we have here because we have to install everything and also have some small activities that we can do. Or more of like exercises. Okay, so thank you guys so much for being here. Today we're gonna do a quick intro to systems workshop. If you guys don't know what systems is, we're basically talking about computer systems and operating systems and being able to use the command line and utilize the different tools that are available for us. And we'll be specifically using Kali Linux, which is a flavor or a subset of Linux, but is catered towards pen testers and hackers. So it has a lot of pre-installed tools that we can use. So I forgot to film the announcements. Whoops. But next week we do have a guest speaker. We have a poster ready for that, so we'll have that posted next week. So if you're interested about hearing some wise words from someone from the industry, I highly encourage you guys to come out on Tuesday, hopefully in this room. But if not, we'll try and work around that. Okay, so before we get started, there's a lot of like lessons and things that I prepared, but because we're going to be using VirtualBox and opening Kali Linux through VirtualBox, I want to make sure that we all have VirtualBox installed before anything else. So if you don't have VirtualBox installed, please go to the links on the PowerPoint slides here, install it, and also install the Kali Linux ISO as well. I'll be going over further instructions on how to the process of getting the ISO onto VirtualBox later on in the meeting. So I'll give like 1 minute for people to do that real quick. And if there's any questions, I think once we get to the duplicate slide for this, I'll go around and make sure we have everything ready to go. Okay. All right. Oops. All right, so here's our overview for today. We're gonna talk quickly about what operating systems are, how they work. It's gonna be really, really basic for anyone who never really got the chance to figure out what the purpose of operating systems were or how they really manifest on our computers. We're gonna talk about Linux and why it's such an important and also widespread operating system that we have here. And then we're going to go straight into our VM activity introduction. We're going to talk about basic Linux commands, a little bit of shell scripting, advanced commands, text processing, network and security, and then talk about some practical projects that you could do and other exercises that you guys could do on your own now that you have Kali Linux installed on your machine. I didn't create any like specific examples, but because I'll be sharing the slides, you guys could use this as a reference for all the different tools and commands that you'll need for future competitions or just using Kali Linux to its fullest potential. And while we go over each command, I'll be hopefully showing how to use it as well, and we'll be able to kind of do it all together. Okay, so an operating system, you guys may know Windows, Apple, these are pretty fairly common operating systems that we have. We also have Linux as well. But ultimately, no matter what type of operating system you have, operating systems are just pieces of software that allow you to manage computer hardware and software resources in a simplified way and provides common services for other computer programs. It's very much like a step or in place between the users and the actual computer hardware. And that makes it easy to navigate around what the machine does. All a computer is just hardware, metal, and it's pretty much bare bones. An operating system actually allows us to manipulate these hardware resources in an efficient manner and in a way that isn't really complex at all. Not everything runs with an operating system. If you guys are familiar with either embedded systems or other microprocessors or microcontrollers, those don't need to have an operating system to run certain pieces of code. But for modern day computers or even potential servers or supercomputers or whatever, an operating system is pretty crucial to be able to schedule and navigate multiple tasks that we're trying to complete. So here's just an extra diagram and images to kind of visualize the role of operating systems. On the top right, we're able to see the system software here, which includes utilities and operating system, and it's acting sort of as a barrier towards the hardware that we have, the CPU, RAM, disk, and any external peripherals that we'll have on the computer. And whatever application software that we have, which could include databases, spreadsheets, word processors, web browsers, or even computer games, these all access hardware resources through the operating system, which is a system level software. So you kind of have two layers going on there. And that being said, the two layers of software can kind of be distributed as either application software or system software, where the system software itself is able to support multiple application software. On the right here, we have a bit more detailed picture of the thing above. We have the green boxes for our hardware, and we have something called the kernel. The kernel is the more specific label for the operating system, and that itself is able to handle the applications that we might have. So yeah, I did create an extra box here and labeled it as the operating system. Depending on what operating system you're using, the definitions for the kernel and the application, the system software might vary, but ultimately this is like a very general guideline of how the operating system works. And here's also a YouTube video for more. I think it's an extensive playlist for like a whole bunch of videos about operating system, but it's very nitty gritty. So if you do happen to be interested on how, different hardware is shared and how the operating system manage that, you guys could check that out. Okay, so now we're gonna watch this quick video. This personally helped me really solidify the role of an operating system and how it manifests within our computer. And ultimately, being able to understand the operating system itself allows us to comfortably access the resources that an operating system might have. So we're going to take some time to watch like a good chunk of this video, and then we'll quickly move on. But hopefully this will provide a good basis on that. Are people on Zoom able to hear the video? Is that a yes or a no? No? Okay, let me go ahead and fix that real quick. Okay, that should do it.
This episode is supported by Hover. Hi, I'm Carrie Ann and welcome to Crash Course Computer Science. Computers in the 40s and early 50s ran one program at a time. A programmer would write one at their desk, for example, on punch cards. Then they'd carry it to a room containing a room-sized computer and hand it to a dedicated computer operator. That person would then feed the program into the computer when it was next available. The computer would run it, spit out some output and halt. This very manual process worked okay back when computers were slow, and running a program often took hours, days, or even weeks. But as we discussed last episode, computers became faster and faster and faster, exponentially so. Pretty soon, having humans run around inserting programs into readers was taking longer than running the actual programs themselves. We needed a way for computers to operate themselves, and so operating systems were born. Operating systems, or OSs for short, are just programs, but special privileges on the hardware let them run and manage other programs. They're typically the first one to start when a computer is turned on, and all subsequent programs are launched by the OS. They got their start in the 1950s as computers became more widespread and more powerful. The very first OSs augmented the mundane manual task of loading programs by hand. Instead of being given one program at a time, computers could be given batches. When the computer was done with one, it would automatically and near instantly start the next. There was no downtime while someone scurried around an office to find the next program to run. This was called batch processing. While computers got faster, they also got cheaper. So they were popping up all over the world, especially in universities and government offices. Soon, people started sharing software, but there was a problem. In the era of one-off computers like the Harvard Mark I or ENIAC, programmers only had to write code for that one single machine. The processor punch card readers and printers were known and unchanging, but as computers became more widespread, their configurations were not always identical. Like computers might have the same CPU, but not the same printer. This was a huge pain for programmers. Not only did they have to worry about writing their program, but also how to interface with each and every model of printer, and all devices connected to a computer, what are called peripherals. Interfacing with early peripherals was very low level, requiring programmers to know intimate hardware details about each device. On top of that, programmers rarely had access to every model of peripheral to test their code on. So they had to write code as best they could, often just by reading manuals, and hope it worked when shared. Things weren't exactly plug and play back then, more plug and pray. This was clearly terrible. So to make it easier for programmers, operating systems were implemented as intermediaries between software programs and hardware peripherals. More specifically, they provided a software abstraction through APIs called device drivers. These allow programmers to talk to common input and output hardware, or I/O for short, using standardized mechanisms. For example, programmers could call a function like print high score, and the OS would do the heavy lifting to get it onto paper. By the end of the 1950s, computers had gotten so fast they were often idle waiting for slow mechanical things like printers and punch card readers. While programs were blocked on I/O, the expensive processor was just chilling, not like a villain, just relaxing. In the late 50s, the University of Manchester in the UK started work on a supercomputer called Atlas, one of the first in the world. They knew it was going to be wicked fast, so they needed a way to make maximal use of the expensive machine. Their solution was a program called the Atlas Supervisor, finished in 1962. This operating system not only loaded programs automatically, like earlier batch systems, but could also run several at the same time on its single CPU. It did this through clever scheduling. Let's say we have a game program running on Atlas, and we call the function print high score, which instructs Atlas to print the value of a variable named high score onto paper to show our friends that we're the ultimate champion of virtual tiddlywinks. That function call is going to take a while, the equivalent of thousands of clock cycles, because mechanical printers are slow in comparison to electronic CPUs. So instead of waiting for the I/O to finish, Atlas instead puts our program to sleep, then selects and runs another program that's waiting and ready to run. Eventually, the printer will report back to Atlas that it finished printing the value of high score. Atlas then marks our program as ready to go, and at some point, it'll be scheduled to run again on the CPU, and continue onto the next line of code following the print statement. In this way, Atlas could have one program running calculations on the CPU, while another was printing out data, and yet another reading in data from a punch tape. Atlas's engineers doubled down on this idea and outfitted their computer with 4 paper tape readers, 4 paper tape punches, and up to 8 magnetic tape drives. This allowed many programs to be in progress all at once, sharing time on a single CPU. This ability, enabled by the operating system, is called multitasking. There's one big catch to having many programs running simultaneously on a single computer though. Each one is going to need some memory, and we can't lose that program's data when we switch to another program. The solution is to allocate each program its own block of memory. So for example, let's say a computer has 10,000 memory locations in total. Program A might get allocated memory addresses 0 through 999, and program B might get 1000 through 1999, and so on. If a program asks for more memory, the operating system decides if it can grant that request, and if so, what memory block to allocate next. This flexibility is great, but introduces a quirk. It means that program A could end up being allocated non-sequential blocks of memory, in say addresses 0 through 999, and 2000 1000 through 2999. And this is just a simple example. A real program might be allocated dozens of blocks scattered all over memory. As you might imagine, this would get really confusing for programmers to keep track of. Maybe there's a long list of sales data in memory that a programmer has to total up at the end of the day. But this list is stored across a bunch of different blocks of memory. To hide this complexity, operating systems virtualize memory locations. With virtual memory, programs can assume their memory always starts at address 0, keeping things simple and consistent. However, the actual physical location in computer memory is hidden and abstracted by the operating system. Just a new level of abstraction. Let's take our example program B, which has been allocated a block of memory from address 1000 to 1999. As far as program B can tell, this appears to be a block from 0 to 909.
Skip a little bit ahead.
This mechanism allows programs to have flexible memory sizes, called dynamic memory allocation, that appear to be continuous to them. It simplifies everything and offers tremendous flexibility to the operating system in running multiple programs simultaneously. Another upside of allocating each program its own memory is that they're better isolated from one another. So if a buggy program goes awry and starts writing gobbledygook, it can only trash its own memory, not that of other programs.
Okay, I think the rest of the video talks more about like other things operating systems do and whatnot, but the first part has a good general introduction of like how the history of operating systems and other the main focus and fundamentals of what they do. So if you guys want to continue watching that video, you guys can check it out on the slides. Okay, so now we're gonna talk about Linux. So in 1991, there was an operating system called Unix, and it was open source. Sorry, I'm completely messing this up. So in 1991, Linux was created as an open source alternative to another operating system that exists called Unix. Linux is part of the Free Software Foundation, or the GNU project, and it's very, very popular with a whole bunch of different evolutions and flavors of Linux. The image at the bottom here shows a whole bunch of Linux operating systems that have been created, and some specific examples that you might see or hear about are Ubuntu, Debian, Red Hat, and Arch. The importance of Linux is that Linux is open source, and there's a lot of freedom that could come with that. There's a lot of customization and as well as community support for this operating system. It is also stable, reliable, and has great performance when it comes to different programs. And it also has really good security and allows for user management. And so if you want to apply cybersecurity to Linux systems, then you would really be thinking about user management and user permissions on a device in the operating system. Finally, Linux has a lot of powerful tools and environments that allow us to utilize different things and utilize the hardware in many different ways. Oh, and Linux was also created by Linus Torvalds, who you can see on the right side there. Okay, so let's see. Make sure. All right, so in the beginning of the meeting, I asked you guys to install VirtualBox and Kali ISO. So we're going to walk through the Kali installation, the ISO guide right now. There's also different ways to install and set up Linux. Today, we're going to use something called a virtual machine. If you guys don't know what a virtual machine is, it basically allows your software to create a sandboxed environment based off of a specific operating system. So a very simple example is that I'm running a Windows laptop, and through a virtual machine, I'm also able to run a system of Linux on my machine using the same resources. And the virtual machine allows it so Linux doesn't really know about doesn't know that it's inside another computer. It doesn't know that it's sandboxed. And so it can't really affect my Windows computer. It can't really affect anything outside of that. There are certain exceptions here and there, but generally this makes virtual machines very powerful and well used. You could also have a dual boot system, which means you're running both Windows and Linux on the same computer, and they work side by side. And you could just have an entirely Linux operating system as well. So, and then go ahead and, all right, so we're going to talk about the installation. So hopefully you guys were able to go ahead and install VirtualBox. If you have any issues with the installation, please let me know and I'll try to help you out. Once you have it running, the VirtualBox manager should look like this as well. For the Kali Linux installation, we're going to install the virtual image for it. And so here for Kali Linux, we go, I think I misclicked. We're able to see virtual machines. And since we're using VirtualBox, we're going to click the 64-bit version of that. And I think, yeah, then it starts installing that. I'm going to cancel that because I don't need it. And I already have a version, but that should take a while. Let me know if you're having issues or if you're able to successfully install it. But once you are able to do that, we'll be able to add a new virtual machine and have the ISO set to that as well. So does anyone have any questions or is anyone having trouble so far? Yeah. I guess you could. The only issue, I mean, yes, you could. When you're installing a virtual or when you're configuring the virtual machine, you do have to allocate like how much of your physical resources it's going to use because it's on the same machine, but you're kind of having it separate to everything else. So you could technically do that, but you're using like a fraction of resources. So there wouldn't really be a reason to do that, but it is kind of a funny thought experiment. While we're waiting, just some extra nerdy knowledge there. You guys might have heard of something called Docker before. Docker kind of does this, to roughly summarize, it does the same thing as what a virtual machine might do, but it goes even further to just applications. So instead of allocating resources of hardware to an entire operating machine, we allocate specific resources just to an application, and it's able to be separated through that. And the purpose of that is so that it's able to be managed a lot better, and there is no installation issues within the software. If I'm running a specific application on Windows and you're running it on Mac, you might have a problem that I might not have. The goal of Docker is to try and avoid these issues by devising the software just straight from the hardware, and it's able to have some better communication and control through that. I'm not too familiar with it myself. I've tried a couple things with it, but it also acts on the same idea. And if you search it up, you find some similarities with like a hypervisor, which also manages virtual machines and whatnot. But we won't go super detailed on those things. This is just to help people understand like what exactly we're doing and how we're able to use the tools for hacking, which is basically what we're about to do. So, all right. So, anyone else have any questions or is having trouble with the installation? Is everyone on Zoom doing all right with that? Okay. I hope that's okay. So I'll now show oh wait, am I sharing? I'm not sharing my entire screen, am I? Let me go ahead and do that. Okay. All right, so this is the VirtualBox Manager, and we're gonna now add the ISO to a virtual machine. So if I already have it installed here, but if you go ahead and click New, you'll be prompted with a couple questions. You have to put a name for the virtual machine that you want. So I'll just put Kali 2, I guess. You get to pick the folder that you want the VM in, and then you select the ISO image that you have installed. So hopefully it should be in your downloads folder. You could just select that installer and everything should be good to go. Go ahead and click next. So here we actually get to determine the amount of hardware that you want and allocate it specifically. I think in general, I don't know the specific amount, but around, so you definitely don't want to give it everything. So just like a small fraction of your hardware should be fine. And for processor, we could just leave it as is. Drive, that should be fine. And once you click finish, you should have the VirtualBox ready to go here. So does anyone have any questions about that? No? Okay. So next we're gonna go ahead and start it. So there's a green button right here. We just select the machine that we want. Go ahead and click start. And it should start to boot up. Does take a small while though. Okay, there we go. Go ahead and boot. So now we have a cute little installation of Kali Linux on our Windows computer. And so if you don't have a way to access Linux, virtual machines are a great way to do that. And during competitions and whatnot, I highly recommend using Linux virtual machines to do certain tasks, especially since Kali itself has a lot of preset software and tools such as I think Jack the Ripper and other tools. So it's very nice. Okay, and I think because I've installed Kali before, it doesn't prompt me with like my password and username, but if you're doing it for the first time, that might show up. So just go through the steps of that, and it should be straightly should be straightforward. Oh no, because oh, I forgot my username. Um, user. I may have to use the second one. I don't. I could have sworn it was root. Okay, I'm gonna do one last time. Hmm. Okay, you know what? It's been a while since I've used it on this computer. We're gonna go ahead and boot the other VirtualBox, and then we could actually go and see. I apologize for that. Is everyone else able to log into Kali and have that open, or are we still configuring? No. Do you need help? Okay. Should just be virtualbox.org. You might be on like a different sublink for that. So that's it. I'm gonna go ahead and try and figure this out. Yeah, I think I'm gonna try and use the second one because I don't remember. Into the folder install. Yeah, I could go ahead and do that. Let me try and make sure it works on no, works on my end as well. Okay, so just to go back to the thing here. So to make a new virtual machine, you're just gonna press new and you're gonna give it a name and then select the Kali Linux file that you hopefully should have downloaded. If you haven't, the link is, I believe, Kali Linux or just kali.org. And when you open, I think it's probably Get Kali. Yeah. So if you click Get Kali, you should be prompted with something like that looks like this. And you're gonna go ahead and click on virtual machines, which is the right one, and then click the VirtualBox version right here. And then once you do that, you link the path to the ISO file. So for me, it was called Linux Kali installer ISO. You put that and then you click next. And then you give it some the configuration options for your hardware, and you should be able to get it to run. So I guess this is a good opportunity for me because I could also just show you more steps on the configuration. So you're going to be prompted with a language and some other information. And it's going to go ahead and install some things.
If you download from the box,
Mhm.
it's not an ISO file, it's like a pre-installed virtual machine.
Oh, is it? Oh, it's not the right one. Oh no, it might be the wrong one.
Installer images.
Oh, okay. Sorry about that. Yeah, okay, it should be this. I'm so sorry. So it's not the VirtualBox one, but it's the virtual machine is the one on those ISO file. Thank you for that. I didn't realize. I think I installed Kali like a year ago. So it's been a while. So yeah, sorry about that. Go ahead and click this and then click the ISO file for that. So sorry about that. So so I'll give some people time to be able to install that and have the VirtualBox set up. It's gonna be a 2-hour workshop for a reason. Okay. Yeah. And I think the installation on the right here is pretty straightforward, so I'm just gonna go through that. So for here, go back. Did I mess up? Okay, so for here, you're gonna put in just like your host name. It just gives me Cali by default, so I'm going with that. I think a lot of this isn't necessary or too specific. So, okay, so this is gonna be like the username. So I'm just gonna go ahead and put user. Should just name a user as well. And just asking for a password. I'm just gonna put a really simple password. Some clock settings. It does take a little while. But after you go through all that, it should start installing all the requirements for the system. Is anyone else having trouble or good? Mhm. Yeah. Yeah. It's really bad at the library sometimes. Yeah. People are you able to get it. Is it working? Yeah. Oh, Anyone on the Zoom have questions? The Yeah, for Windows, I think the 64-bit version, unless you're running a 32-bit computer. I'm just gonna continue with the configuration here. Not gonna change too much because I don't think it'll be necessary, but at least for the basic. If you're on a specific step and you just need some directions, I'll also help out. So just feel free to ask and I'll show it again. I think you could just put for the you could just I think it has Kali as default. You could just do that. I don't think it'll be super important for the time being. And I think you could always change it too if you need to. Mm. Taking forever. Oh. They require you to have your be like to the proper one. And then we eat it. Yeah. Like that really. No, because even like for example, my hair and people look always like my hair. If you can't have your hair all over your
No, because.
Okay, so I think since we have we need to wait for it to load. I think what I'll do is I'll go over the rest of the slides, just talk about what are some basic things that you could see from the Linux system. And if we have time, we'll try and use these commands on the console just to show that it's working. But yeah, so if you have any questions also, feel free to interrupt. I'm just going to be quickly finishing things up here. So, all right. So basic commands. All right, so in this slide, we'll be talking about file systems and being able to navigate files, view files, and operate with files. So on the top left, we have PWD. So if you print PWD, you get to see your current directory for where you are, and you're able to navigate around different directories that you have. I forgot to put an image of the Linux file system here, but there's going to be a whole bunch of directories that you're in, and you're able to navigate around each one using, you're going to be able to change the directories using CD. And I'll definitely show these main four commands because it's the ones you use most often, usually, especially CD and LS. But there's some commands for that as well. Echo, it just prints a string in the console. If you do echo, whatever, hi, I'm Linux, and it'll just type it in the console there. So other commands for viewing the files, you have cat. So if you put cat file name, it'll print the outputs, it'll output the content of that file. You also have less, which is similar to cat, but allows you to view contents one page at a time, and you can kind of click to see the next page. We also have head and tail, which displays the first few lines of a file, and tail is vice versa. That will do like the last number of those. Going down to the bottom here, we also have flags for the commands. So the commands that you're able to use will have different options or configurations with them then that allow you to do certain things. And you'll be able to find out all these flags using the man command. The man or manual command is very special because if you don't know the specific flags or specific command or what it does, you're able to do man and PWD, for example, and then you'll know everything about that command and what it does. And again, mostly I'll try and show these commands in action because they're fairly important. But for now, we'll just be talking about them. We also have some other file system operations here. Touch to create an empty file, make directory to create an empty directory, copy to copy different files, move to move files from different directories, remove to remove a file, or the -R flag, as you can see here, to completely remove a directory. Yes, okay. So on. You also have the remove directory command here as well. So yeah, these are basic Linux commands for file system navigations and writing to files. We'll talk about how to actually write to files within the console later. But we also have other text processing commands here. The three most common ones you'll see are grep, awk, and sed. Grep is very simple. It stands for Global Regulation Expression Print. And if you do grep a string or a pattern and file name, it will go through the file name and then print only the lines that include the strings that you give it. Awk is similar to grep as well. The cool thing with awk is that if you use it with table data where each column is identifiable with a certain symbol like a comma or a colon, it is able to go ahead and print the number column that you pick. So if we give the command print $1, it'll print the first column of the file. But again, you got to make sure the file is ordered correctly and labeled correctly. and that each line has columns separated by a specific symbol. And I think there's flags that allow you to do that, and determine what that symbol is. So next is sed, which is the stream editor. And this allows you to replace certain texts with other texts. So here we have sed, old and new. And so it replaces the old string, whatever string you put in there, with the new string that you do tell it to. So that's a quick description of that. And you guys could always Google these commands up on Google for any more detailed explanations of what's required and whatnot. But you'll be using this a lot, and it's very helpful, especially when you're, trying to find flags in specific files as well. Okay, let's see what the installation. Let's check up. Okay, still taking 1 million years. Wonderful. Okay, so now we're going to talk about text editors. So yeah. Oh, I forgot to put piping, but that's all right. So to actually write in a file, we use different text editors. There are many text editors that exist. Some of them you might have heard of. Here I'll be talking about Nano, Vi/Vim, and Emacs. So essentially, these are all just text editors with different interfaces and different commands. In a very simple way, you could think of it as like a very complex like Word doc, but it's able to be accessed on the console. So depending on the type of text editor you want to use, you have to know the different commands to be able to navigate or do the same thing with them. If you want to save changes, for Nano, it's Control 0. For Vim, it's going to be :WQ or :X. And to save changes with Emacs, it's going to be Control-X with Control-S. So, the goal isn't to learn all of these text editors. Generally, you want to pick one that you like using, and then learn the necessary commands for that, so that whenever you have to write something to a file or you have to do something with a file, you just open up your preferred text editor and you do whatever you need to do, and you learn some commands here. Okay. So yeah, that's text editors in a nutshell. We're also going to be talking about shell scripting. So once we're able to write files and use text editor to write to files, we're able to write scripts. And just to talk about the difference between programming and scripting, programming is the scripting and programming are very similar, but in nature, scripting deals with a lot of the hardware, or it deals with a lot of the commands we talked about, where programming is usually built with a specific language. So for example, in this text box that we have here, this would be an example of a bash script. On the top, we have something called a shebang line, or shebang line that references the type of script or the type of shell that you want for your script. And in this case, you can see that it is bash and it's located in the bin folder. So as we talked about previously, one of the commands that we went over is just hello and string. If we have, let's say this file has echo hello world, right? And it's just that. If we execute that file, it will go down the script here and then execute the commands that are listed. So I want to be able to show that once we have that working, but again, all the stuff that I talked about is here. And in order to actually be able to run the shell, we do have to give permissions and allow the file to be executable. And I don't know if I mentioned it was on the previous slide, but the command chmod is the command that allows us to modify permissions for specific files. This is really important when it comes to user permissions and being able to set all that. I won't specifically talk about user permissions here, but I highly suggest looking that up on your own time if you end up doing more sophisticated stuff with Linux as well. And once this command here, +X, allows it to be executable, and then running it through /script.sh will be able to do this. This cool thing about Bash scripts is that you basically condense a whole bunch of commands into a single executable file. And you could also, depending on what type of shell you use, you could also implement different types of logic. So here we have some variables such as name, and we're able to print that out. We also have a conditional statement or an if statement that checks if the variable name is John. And depending on that condition, we're able to do two different commands or sequences of logic. So very similar to programming, follows the same programming ideals, but scripting is used for some other purposes that you can see on the left. It can automate system maintenance and tasks like backups, disk cleanups, and log rotation. This is all, it comes in handy when you also allow it to run at a specific time. If you set the system to run a specific file, let's say at midnight, you basically automated that system, and you don't need to manually do everything yourself. So scripting becomes very important. And yeah. The next is batch file processing. You could rename files, process multiple files, and convert different file formats. You could monitor systems and alerts. So you could check your system health, disk usage, and you're able to send notifications depending on anything that's going on in the system. And finally, you could also deploy and configure and have management over your configurations, where you're able to automate either software deployments, configuration changes, or also other environment setups. Okay, just do a quick check. All right, so you also have networking and security functionality with Linux. As I mentioned earlier, here is the permission commands. Here we have chmod, and we also have chown. Chmod has, as we talked about, you give it a certain amount of permissions and a specific file, and it's able to go in and change that. Chown will change the owner and the group of a file. ls-l also lists all the files that you have. Regular ls will just list the files in directory. -l will give you more detailed information, which includes ownership and permissions as well. To go specifically into permissions, we might talk about it, or we'll definitely try and show it later, but user permissions are in a set of 9. So one set of 3 is for the owner, I think it's the user who made it. The second set of 3 is for a specific group that you can set for different users. And lastly, the last 3 is set for anyone else. And these 3 sets, the 3 bits you have for each group, represent whether a user could read, write, or execute a certain file. So it's ubiquitous among Linux, and it's also how you're able to know who's able to do what for specific directories and files. For networking and security, we also have some tools, simple tools that we're able to do regarding that. Ping is a very popular one. You could send certain request packets to different network hosts. So if you're connected to a network, you could send different packets to different servers. An example, hopefully, that I'll show later is ping 8.8.8.8. That's the IP address of, I think, Google. So you could just ping their servers, and hopefully you should get packets back showing that the connection has been received. ifconfig displays network interfaces and allows you to configure them as well. I think ipconfig is the newer one too, depending on the version you're using. IP address or ADDR displays IP addresses and network interfaces. Netstat displays network connections and routing tables, interface statistics, and stuff like that as well. And finally, SSH, which is a very popular command, allows you to remote connect to different computers. So this is really important because if you're thinking about hacking different computers, if I went to someone else's computer and just did a whole bunch of stuff that I'm not supposed to do, yes, that's hacking, right? But I have to physically be there at that computer. SSH, although the function itself allows you to access things from a remote computer that might be yours, that also leaves the vulnerabilities that might allow unwanted users to make changes to a remote device. So a lot of basic pen testing activities and topics use SSH as an example, where you have the IP address and the username, and maybe you fish out the password, and you're able to log onto a certain person's device using SSH, all from your own remote setup. So very common one, and it's probably the one that you'll use most when it comes to networking related activities. Okay. Just checking up, almost done. So hopefully it'll wrap up after we finish the slides. Lastly, we have, sorry, I'm losing my voice. We have package managers. So you could install different programs or tools that may or may not already be installed. An example of a tool for a pen tester might be Metasploit, which allows you to automate packet insertions and be able to, it makes hacking a lot easier and allows you to send packages to different computers. And so the command for that could be, I think it's like apt. So if you do sudo apt install Metasploit, you'll be able to install that. The word sudo is also a term you'll see a lot. It basically asks for admin or root privilege. So if you just do apt install Metasploit and you're on a different user, the operating system might say, hey, you don't have access privileges to be able to install. If you just use sudo apt install, then you'll be able to bypass that and install what you need to do. Sometimes it might also ask for a password depending on how you configure it. But that said, you also have apt update, apt upgrade, apt install, and apt remove. And I think based off of the flavor of Linux you have, you might have different subwords or different names for the commands to install it, but all the ideas are the same. You're able to install it, update it, upgrade it, and remove it as needed. So yeah. Okay, other advanced commands that exist too, we won't talk too much about them. We have the find command, which allows you to find directories and paths by name. So if you can't find something, you can use that. We also have location, which also does a similar thing. We have PS, which I'm not sure if I have included PS before. PS, if you run that command similar to ls, it'll show the listings of the files you have. PS will show the number of processes that are running. And so it's super useful for pen testing when you're able to see what a computer is running and what processes it has, so that you're able to do some research and find different vulnerabilities based off of whatever applications that they're running and be able to execute a malicious package or whatnot. And with that, you also have kill and kill all, which is a command for killing certain processes that you have running on your computer. And you have BG and FG, which if you're running Vim, which is a text editor, if you're running any type of text editor, and actually it might be different, but as an example, if you, let's say, want that application to run in the background, you don't really care about it, and you want to do something else, you'd run BG, and then it will it'll still be in the list in PS, but it won't be in the foreground, and you won't be able to see it happening. It'll be handled behind the scenes. Finally, you have some commands here for archiving and compression, such as tar and gzip. Gunzip is also one as well. And you also have different flags there to configure what kind of package that you want for that. Okay, let's check on this. Oh, what is this? Okay. Sure. Don't remember doing this part. See if I can do it. Okay, give me one sec. Um, okay, yeah. So this one, I'm just gonna set the bootloader to the already preset one. And it should do that. And hopefully we're done. Let's find out. No, okay. Well, we're for that. Is everyone else doing all right? The installation? Have trouble? Any questions on people on Zoom? Oh, that's not good. Okay, that should be fine. Okay. So I have Kali slowly booting up. And hopefully if all goes well. Yes, okay. So it'll ask me with the login here. Are we able to get it working over there or still having some trouble? You got it? Okay, sweet. So I'm gonna enter my information, credentials. And I should be able to get logged in. Right, sweet. Here we are. So we got the web interface for Kali here. Pretty sick. Anyone else having trouble that needs help? No, okay. Anyone on Zoom? Are we all able to? I guess we're just waiting for the install. So I'll go ahead and wait a bit. I'm actually gonna get some more water and I'll be right back. Yeah, please. Not VDI. Um, may have downloaded the wrong thing. Uh, so I was mistaken for the ISO. It's actually found on the installer images. And for VirtualBox, if you click download here, it should, if you're on Windows, you should click the Windows host here and it should install for you. Is that the one you picked, or is there something that else might be weird? Hey, one. Oh, you got it? Okay. No problem. I think we're ready to go ahead and kind of show you the different commands here. So I will be going back and forth, but so the icon on the top left here next to Firefox is just the console tab. So we click on or the terminal. And so once we have that, we are able to get a prompt here. I can just type in whatever. This is where I type in the commands and it's able to do different things. So, all right. So for the first example here, I'm able to do ls, and then it shows all the different directories that I'm in right now. Currently, I believe I'm in the home directory. So I have different access to all different files. If I go to CD, if I go to different directory using CD, like documents, you can notice that the file path changes here at the top and that I'm in a different file. I don't have anything yet because this should be a fresh installment, but you could see that it's we're in a different directory. You could also do something important and use dot notation. So if I'm in a certain file and if I do cd dot, nothing actually changes. So dot just refers to my current directory that I'm in right now. If I do cd dot dot, that actually takes me to the directory that's one back, so the parent directory. So now we're in home, which is different. And so if we do cd, I think root, no, it's not it. But I guess just keep doing cd. cd, okay. So right here, this is actually the root. Where we were originally was the home directory for our user. So our main user here, but at the actual root, we have a whole bunch of folders here that store different dependencies, softwares, and information. So we're actually just gonna do cd tilde. I think that's what it's called. And that'll actually take us back to the home spot here. So cd is the one that I use the most just because it's where I navigate different directories. And so I end up using it a lot along with ls. If we do pwd, it's going to tell us where we are. So right now we're in the home user directory. And if we do cd documents and we do pwd, it shows that we're in a different directory. If we do echo and just a string, oh no, I probably shouldn't put quotes. Hello, it's just going to print out hello on my file. And something pretty cool that we could also do is, let's see if we can show that. File. Should probably go ahead and make a file first. So we could do touch my file. We get the my file directory here. And if we use like a text editor, like we showed before, like Vim, my file, we actually get the text editor up here. So I used Vim before, so I'm familiar with just like the basic commands of how to type stuff, but I'm in insert mode. So if I write something on my file and I save it, if I do cat my file, we get the contents of whatever's in there. Yes. I don't know what that is. I put quote, ignore that. Press Control C. Yeah. So if I keep doing Control C, that's just command to clear. So if I do something where if I'm stuck in a place, Control C often gets me out of those situations. Sometimes it's Control D or Control Z, but depends on the program you're running. Okay, so let's see, what else can we do? We could do make directory. So actually, if we could go back and we do make directory, my directory, see that with ls, is it not here? Where is it? Yes, so that's the directory could be seen here as well. Another flag we could do for ls is -a. which shows us all the hidden directories or the hidden files that we don't see. And so if we just do regular ls, usually it hides different, I guess, files that aren't necessary in what we're trying to do. But sometimes maybe in like simple CTFs, they might hide like a file there that you might need to get a flag from. So let's see. Okay. We also have move. Oh, let's do man. So if I have man and the move command, we actually get a whole user command directory telling us the different options for what that command will do. And we could just, I think we could scroll down and see all the different flags that might be included and how to utilize this command. So for move, we try and use this. So we have options, source, and the directory. So I think that's pretty much simple. Press Q to quit. So if we have move /documents / my file, because my file, we made it in the documents directory. So if we use / notation to represent where that file is, so dot the file we're in now, or sorry, the directory we're in now. So we get all of this / documents, the directory in documents here, and then the file name. And if we also do dot here, which represents where we are, hopefully this should move, it should move my file to where we are. So pretty cool stuff. And definitely very helpful when moving around different things. And yeah, I think that's pretty much all for that. Just to show you like an example of grep. If we do file, actually, let's go ahead and let's go ahead and add a bit more lines here. So if we, let's see, show that cat, we have 4 different lines. And if I remember how to use this correctly, if we use line and as the keyword and the my file as the file, it only prints the lines with the words line. I think Kali does a cool job by highlighting it as well. But this way, if we have a really big batch file and we want to look for specific keywords that we have, then we could use grep to really easily pick out the lines with the words that we so. Okay. One thing that I also want to talk about is, I think, pipelining. So if I do echo hello, that will just print out the line. But if I put a arrow key, I think 2 arrow keys and a name for a file, it should go ahead and put echo or the output of the previous command. So hello, I am here, into a new file called file2. Yep. And if we want to concatenate or add to file2, we could also do something like that where we put in a string or some line and we just use 1 arrow key and then the file name. And then we should see that there are, oh no, the first arrow actually means it overwrites the file. And the second two arrow keys either creates the file or concats it. So if we go to file2, yeah, so now we have 2 lines there. So 1 arrow pipelining completely erases what was previously in the file with what the output was previously, and then 2 arrow keys makes a new file or can adds to an already existing file if the file already exists. Yeah. Okay, any questions so far? Is everyone good with the installation or is still loading? Okay. Sweet. So see, oh yes. So you guys could also try out the text editors if you want. A common thing to do is a common mistake that happens though is like you would enter a text editor and you won't know how to get out. So if you need to do that, just you could either try Googling how to do that, or I have this is like a quick cheat sheet to know how to interface between the different text editors. So you could play around that in your free time. And the last thing I want to do, I want to keep it pretty brief. We could go ahead and PS here. Okay. So I'm actually gonna run PS. So right now we don't have many programs going on, but if you do PS-A, maybe? Is that a command? No. Okay. So PS-L shows a bit more information here, but what the regular PS, we talked about how it shows the list of different processes. We don't have much going on, but we're able to see that right here. And we also have more information with that running PS-L. We could also run ls-l and it'll show you all the different directories and files. And as mentioned before, we're actually able to see information on the different file permissions and directory permissions using this command. So yeah, also very useful. Okay. So don't think I could show off SSH, but I can definitely show you just a quick ping. We did ping 8.8.8. It shows that we're getting packets back from the Google server or the IP address that we sent it to. So ping is a very good tool for, and you could stop the command using Control-C. I think it'll continuously try and send packets, but it's very useful to know if something's able to, if the network is connected and you're actually able to reach the computer. As an example, before SSHing, you might ping to the address, make sure it's online, and then SSH into that machine as well. Let's see. Okay, I think that's pretty much it. I guess one last thing I could do is just show you the quick remove. So if I want to remove a specific file, it should go ahead and do that. One thing to be wary of is that Linux is very powerful. And so whatever command you give it, it will generally run. If you tell it to delete an entire directory, it will delete the entire directory unless you give it the safety flag. So there's you could just delete there. I'm pretty sure you could just delete the entire root folder if you asked it to. So just whatever if you're trying to remove something or configure something, just double check and make sure you're not doing anything really critical or something that might break the computer, because Linux will let you break the computer if you tell it to. So just to be wary about that. Okay, other than that, I just did a whole bunch of Googling and I ChatGPT'd some some things that you could do. So you could write if you wanted more practice with Linux and maybe some project ideas, you could make a simple automation scripts for either monitoring different logs or alerts, as well as backup scripts. You can try making scripts for network configuration. You could try and set up your own web server or automate other network configures and management. You could have tools for system monitoring, where you could create scripts that will integrate other tools that you already have into one single purpose as well. So finally, I want to leave you off with this list of a whole bunch of resources. Some of these are more dense than the other. The first one is super heavy, so I wouldn't necessarily recommend it for beginner users for Linux, but I think the fourth one, Linux Journey, is a super good I guess program to learn Linux, and it's very user friendly. It goes through a whole bunch of different topics that I talked about today, if not more. And so I think if you're interested in systems configuration or security dealing with Linux systems, highly recommend checking that out. If not, you could also look at other links here to learn how to use Linux for specific security purposes. Over the Wire is a really good website that has activities for pen testing, and it uses different Linux features and skills. I don't necessarily recommend it if you haven't already had experience with Linux fundamentals, but if you're interested into getting pen testing and using Linux and the tools that it provides for that, then Over the Wire is a very popular place that people recommend to learn how to do that. Other courses here, some YouTube videos that I put. I think this one,
Hey guys,
learn Linux, and I think this else. I think that might
I
be
knew I was
Crash
underwater.
Course to Linux.
I just didn't realize I was.
Oh, I think, oh, okay. So the last one is also just the entire series of the computer science video that I showed early on, if you're interested. But, there's a lot of resources for you to be able to learn this, and no one could really teach it to you other than yourself. Thankfully, there's a lot of stuff that you could use to learn about it, but you really need to sit down, spend the time, play around with Linux, and to really explore it, to be able to become familiar with the environment so that you can use it, use the tools that it provides. So other than that, I will post a slide, so definitely recommend checking out different links, seeing what works, and kind of creating a schedule or regimen that works for you based around what you want to learn and what kind of skills you want to really grow. The earlier on you understand the fundamentals, later on the more complex stuff becomes easier. So again, really recommend taking the early step in that. Okay, that's pretty much it for me. Thank you guys so much for attending this workshop. If you have any questions or you need help with configurations or other issues with Kali, then I'll spend some time going over that. But other than that, that's all for me. So thank you guys so much. Does anyone on Zoom have issues? Yeah, no problem. Thank